Good morning, good evening, good afternoon, boys and girls. So today we are going to learn about Eigrp in a practical lab scenario. This is Packet Tracer. So let me just validate I am sharing the correct screen with you guys. So let's go ahead and read this scenario. In this lab activity, we will learn how to configure the routing protocol Eigrp using the network shown in the topology diagram. A loopback address will be used on the router too to simulate the connection to the Internet Service Provider, the ISP, where all traffic that is not destined for the local network will be sent. Additionally, some segments of the network has been subnetted using VLSM. EIGRP is a classless routing protocol that can be used to provide subnet mask information in the routing updates. This allows to correctly have the VLSN information being propagated throughout the network. So let's start with the first step. Um, the cable network that is similar to the one in the topology. The activity we begin with the initial network workspace. We already have the packet tracer topology. We don't have to worry about that as far as I can see it. Mm, it says to clear any configuration in the routers, but we're just going to see if there is any configuration in the equipment. Let's just check router one. Let's validate it. I don't see pretty much any information configured on the devices, just the host name. So let's just ignore it for now. Configure the interfaces, verify the IP addresses, and start with the EIGRP. Okay, so let's see if the interfaces are configured on these devices. Let's do the show IP interface grid. Nope, nada. Nothing is configured, so let's go ahead and um, let's go ahead and do the following. Let's go ahead and see how can we configure the interfaces for those devices. That's the big mystery. Okay, I don't see the option here, but we are going to work along with the routing table. So let's go ahead and work with the routing table. And let's see which interfaces we need to configure for router one, for example. The CLI, I see FA00, 0000, and 0001. So let's work on those for now. Config T, interface FA00, IP at 172.16.1.1, and this is the mask. Let's do a node shift. There you go. Exit. Let's do an interface serial 000 IP address 172.16.3.1. 255.255.255.252. Let's do a node shift. There you go. We're missing the other one is for the serial 000 001 IP at. Now we have IP space at, and then 172 is actually 192. 192, the 168, that 10.5. 255, that 255, that 250. Let's do an offshoot. And we are done. We are done with router one. Let's save the configuration with N or WR. Let's move on. Let's close router one for now, and let's move to router two. We are doing the same. Let's go ahead with the enable config T interface FA00 IP at 172 that 16 that 201. This is slash 24. This one not shoot. There you go. Now, what else are we missing? Everyone has a PC connected, so pretty much FA00 have will have to be configured on all routers. Let's go with the serials. Let's go with exit for now. Interface serial 0, 0, 0 IP address. Let's do once we do that 16.3.2. This is /30/30. It's gonna shoot. Let's move on to the other one. It's actually the serial 0, 0, 1. In this case, we're going to do the same, but the IP address will be the 192, the 168, that 10.9. Let's do another shoot. And the protocol will be down, of course, because the other side at router 3 is not configured. Exit interface loop, but this is actually 0. This is the one that goes to the internet IP address. We have 10.1.1.1 and then /30. This is like a simulation of an default route that is connected to the internet or a specific interface connected to the internet. So just for you guys to be aware. Now shoot here, we are all good. Actually, it was already up, so we didn't have to execute that no shoot command. Let's do an end and WR, and we are done. Let's move to router 3. We're closing router 2, so we don't get confused. And we have to configure router 3. So let's do enable, config. Let's do interface FA00 IP address. And it's actually 192. Remember the space is important. 192, the 168, the 101 /24. And we have exit. We have no shoot here. And we have exit. And we can do interface serial 0, 0, 0 RGL. This is 192.168.10.6. And this is 255.255.255.252. This one not shoot. And now we are almost ready. We need to work on the other serial. Let's do an IPI. 192.168.10.10. 255.255.252/30 and not shoot. Okay, it is up. Let's do an and copy running config, setup config. Now let's go show IP interface brief. Show IP interface brief. Hopefully we will be getting that soon. Yes, amazing work. What else are we missing? Are we missing something? No, we are fine. We just need to do an N and a WR. Windows Shift, Control Shift 6 if you get this error. Let's do a WR and just set the configuration. Okay, what else are we missing here? Okay, we need to start configuring Eigrp. Let's see if there is any improvement in the result of this lab. We got 42%. So we are pretty much done with the first part. There is a bandwidth information that we are missing. There is some information in router 2, like console. So we might have to work along with some important details here. There's a deprecated command there. We're still missing a lot of information, but we're going to work on that. We're going to work on that. Nothing to worry about. Let's see if, okay, we need to configure the host name and the passwords. But does it says what is the password that we need to configure? That's an important deal. It doesn't really matter. It doesn't mention which passwords. So Let's just create any passwords there. Doesn't really say like a specific password. Okay, message of the day, banner mode, all that. Let's go ahead and configure this. And let's go ahead and go to router one first, and let's do it. So we have config T. Mm, no NS lookup, DNS, and the big detail is no IP DNS lookup, but for some reason it's not working. Let me just do some research because it was supposed to be easy, but it's more difficult than we expected. Let's see if there is a way here to do the no as lookup. Currently, it should be easy. Let me see if we are missing something with the not as lookup. No, let me just do some research here. Let's go to GTP to ask him how to do the NS lookup. Okay, let's just go ahead and copy paste this. I need to do this for R1, R2, and R3. So I'm just going to copy the configuration. We need to remove the emojis. Please nicely separate it. So let's wait so we can have the configuration for those devices. And nice. Let me just copy and paste this. This is the configuration for router one. Let's see if we can take it there. Okay, we're having a problem there. Let me just go ahead and save it here. So I can just copy and paste it there later on. So I need to remove these spaces because it's giving me a hard time. But basically, we're just configuring the main information, the password, the host name, the enable secret, the no IP domain lookup. That was the correct command. So that's what we were missing before. Just copy and paste it. This is not supported. It has to be either telnet or SSH. Let's just SSH. Let me just run again and copy and paste it there. Yeah, it now works. Now, same thing for router 2. So let me just copy and paste it. Actually, the password is Cisco123. So maybe it is the same password for all of them. We just have to be patient about it. Let me work on something real quick. This is WR. Let's do a show run just to cover our box. It is encrypted. So maybe we enable the password service encryption. Let's go ahead and go to copy this configuration and paste it there. We're going to do the same for router 2. We remove this one and then just work on this. Okay. Okay. What are we? What do we have here? Okay. Let me just copy this and hopefully it will be done soon. We close our one and we go to router 2. Let me go to router 2. Config T. Let me just paste it there. And there's an error there. There's a T that we need to remove. Let me try one more time. Let me do an N and a WI. Same thing for router 3. So let me just copy the configuration and do the same. So we just put and paste it there and remove all spaces. And this telnet is not required. We are almost done with this, but we have to be careful with those spaces. It didn't specify a specific password per se, as far as I remember, but we will look into that in a moment. I close R2 and I go to R3 and I just do a config T and paste it there. Let's do an end and a WR. Let's validate if we have to do a specific password for that one, just in case it tell us to do a specific one. It doesn't really tell us. It doesn't really tell us. Let's see if we have any improvement in the results. We are at 46%. Want to see if we have an improvement now with this. Looks like the password is incorrect. That is strange. I'm wondering if the password must be Cisco for those line gun zero. Let's try that. Let me try that. Config T line gun zero password Cisco. Then login. Did we get any problem there? Or will it be class? Now that's what I get confused because it doesn't tell us what is the password that we need to configure. It looks like we might just be missing the password is still incorrect. That's so strange. The line con zero password, but that's what got me confused. I'm going to stop the recording to do some investigation so I can figure out the password. Password. Class. Let's try class. Categories. Zero. Password. Class. Okay. Let's see if that's changing something. Three. No. Password is not correct. Password. Increasing. Oh, doesn't make any sense. And 9.00 password Cisco. 9.0 login synchronous. Okay, this password SQL and login synchronous. Okay, looks like we need to follow this one. It's actually a password Cisco and then login synchronous. So let's go ahead and do that in all routers. Let's go ahead and do it in all routers. Starting with router one. Let's work on it. So the first thing we do, and I will check this website with you guys later so you can have the configurations. Line config T, line from 0, and then we have password Cisco. And then we have login, then login synchronous. Let's do an N and a WR. Let's validate if there is an improvement. Looks like we finally did it for router one. The bandwidth is still missing, but we will work on that later for the serial interface. So we got it. That is the one. Let's work on the other one. Let's go to router two and let's validate the configuration for router two. It is actually the same. It is password Cisco. So let's do that. Let's go ahead and configure it. Config T, 19.0. Then we have password Cisco. Then we have login. Then login synchronous. And then WR. Perfect. What are we missing, guys? Are we missing something? We are missing router 3. So let's go to router 3 and let's do the same. Let's go to router 3 and let's configure that. Config T. 9.0. Password Cisco and login synchronous. We are done. Okay. Now let's continue with the lab step by step. And at the end, we're going to just check on those things that we are missing. So let's go ahead and add config T, router Eigrp 1, net 172.16.0.0. Now the wildcard mask, this is the calculation. The wildcard mask net 92.168, that's 10.4.0.0.0.3. Then enter. So we subtract all 255s for the mask minus the slash 30, which is actually 255.255.255.252. This will give us a wildcard mask of 0.0.0.3. This is the one that we are currently configuring. Let's do an end. WR for now. Let me stop sharing the video so we can focus in the lab. Perfect. Let's go to router 2. And let's go ahead and minimize this one. Let's work with this config T. Router Eigrp1. Net 172.16.0.0. Then enter. Okay, nice. We can see the neighbor with the following command. We can actually see the neighbor that just popped up, so we can add it here. It's coming via serial 000, so those answers are there. Let's continue configuring what is missing. Net 192.168.10.8.0.0.0. And we're pretty much done. Let's go to router 3. So we can take care of that. Config T. Router Eigrp1, same process. Net 192.168.1.0. Net 192.168.10.4.0.0.3. We have the is copied by a serial 192.168.10.5. The neighbor is in that and is traveling through serial 000. Net 192.168.10.8.0.0.3. So 0.0.0.3. And we're done. That's pretty much everything that we need to do here. Now, there was something that we were missing. The bandwidth. So we need to be with a different bandwidth. So let's work on that. Router 1, let's do config T. Let me paste this. Okay, the bandwidth is 64. And let's do the same for router 2. Let me just copy and paste this in the notepad so I can work in that. Just copy and paste it there. Just copy and paste it there. Where is it, guys? Router 2. So let's go completely here and paste it there. Okay, same thing. We are working on the next router, which is R3, router 3. You just copy and paste it there. Let's go to router 3 and let's paste it. Nice. What are we missing, boys and girls? Try IP route is one of the important commands. Let's go to router 2 and let's do a do and paste it there. There you go. So this is actually the best route because a successor is a neighboring router that is currently used for packet forwarding. So what is the best route to PC1? And we are working in router 2. So the best route is actually this one, 0, 0, 0, 0. Okay, the important is to know why, because we need to get to that specific network. It's actually 172.16.0.1.0. What is that one? Do you guys see it? It's this one over here. Is using Eigrp as the administrative distance and is connected through 172.16.3.1. Do you see that in topology? Can we see it there? 172.16.3.1. That one is the serial 000 in router 1. So router 1 probably somewhere around here, one of those two. Is actually this one because it's coming from router 2. So that's the easiest way to get from router 2 to that specific PC. Now the next question is about, let's see, configure the bandwidth. Okay, what is the name of the successor on this route? Let's go ahead and check on that. We are still working in router 2. So 172.16.3.1 is the successor. 3.1, where are you, buddy? This one seems to be the correct one, but I don't see it. It's actually in router 1, so let's go to router 1. Let's do the same command. Let's do a do. Let's do an end and paste it there. So it's not a headache. There you go. Now, the best route is 172.16.3.1. So it's actually this route, directly connected route via 0.0.0.0 to get to that. And that is basically the successor. So I'm trying to validate if there is more clues that tell us why the visible distance is the lowest calculated to the destination. The name of the successor of this router. It's probably referring to, since it's the directly connected network, is the most closest to the specific path that we're trying to reach. That is showing the successor. Because it doesn't really show us like a metric. It just says it's the directly connected one, and that's it. Yeah, that's pretty much it. Doesn't show us like a metric. And the visible distance on PC1 is on. We see that in this router. And we see this visible distance is actually this one to get to the specific PC. What is the PC or router 2? 172.16.2.0. That is the network. So I'm wondering for PC2, what is the IP address that we currently have? It's 2.10. This is the correct connection. That's the way, because we are talking about the visible distance. What is that? Let's just validate here. Is for, it's like 40,514,560. That is the feasible distance on that PC to get to PC1. But are we working in this specific router? Are we working in router one? Was it in router two? Yeah. So we're working in router one. So let's see what is the IP address for router one. Let me just go up. Give me just a break. Okay. Router one. Yeah. It's pretty much the 172.16.1.0. We were getting that feasible distance. Now, what I'm a little bit confused is the IP address that is a little bit different there. Is 1.0, so I'm trying to figure that one out. Let me just close the other one so I don't get confused. That is the feasible distance, but we are getting via 172.16.3.2. So maybe this one is the one that connects us to the PC via the serial interface, something like that. Because I'm not seeing that 192 and 168 at 1.0. This is another advertised distance there. Yeah, pretty much. The one that is with that feasible distance is probably counting the administrative distance and the feasible distance. Okay. Now it says that we need to disable EIGRP summary. So let's go ahead and work on that. The feasible successor and the feasible distance. Do we have a clue when we run this one? It doesn't really tell us. We just have to know the highest one is the feasible distance and the lowest one is the reported distance or administrative distance. That's what we need to know. So let me just go ahead and not focus in the questions primarily because we already went over the theory, but let's focus on configuring the node to summary here. Router EIGRP1 to node to summary. Let's do an N and a WR. Let's go to another router. Let's go to router 2 so we can work on this. Let's do the same. Config T. Router EIGRP1 node to summary. Why are we doing this? Disable automatic summarization on through routers with the node to summary command. It is essential to stop some advertisements that are needed within the network and for EIGRP to work better, but that's pretty much what we know. Let's finish with the last one. It's actually R3. Let's do a config T. Router EIGRP, one node to summary, and there you go. You can see there is a resynchronization between all routers. Maybe we can run the IP route on R3. So let's see if we have more information here. We have the reported distance, which is the lowest one, and the administrative distance, which is the highest one. But these two are having the same administrative distance. So maybe there's not a feasible successor here because these two have the same one. There's one that has like an administrative distance between those two, like in the middle. But in the example of the theory, when we have a similar scenario and there was not a feasible successor when that happened. So that's what I was telling. There is not a feasible successor in this one. Let's see if these give us more clues. Okay, we have to configure the loopbacks. There is a couple of loopbacks that we need to configure them. So let me just copy and paste it. The configuration. And let's just remove it. Now, what I am a little bit curious is if we're going to get to 100% this lab because it has not been an easy one. We'll know. Let's go config for now. Paste. Let's go ahead and validate EIGRP. Maybe we need to add more information. Let's do it. those two networks that we're working along. Those, let me just go ahead and paste it here. There you go. Let's look at the IP route. In this case, we can do it with do, then paste it the command. There you go. Those are the devices. Okay, I don't see that administrative distance there. Let me see, 192, 168, that one, the 0 to the 0. They only seem to be directly connected, and that's it. Yeah. Oh, there should be in router one. So let me go to router one to see if I can see that. Let me just I just closed that one because it's a little bit bothering and distracting. So let's just focus on this one. Sharp it out. We are in router one now, and we can see the administrative distances and all those informations there that are coming from the different networks that we are getting through. We are getting to know via the routing table that we have in router one. Okay, let's go here and work on this IP summary address. And this is actually R3, so let me work on this. Remove the unnecessary spaces and characters. And let's copy and paste this in R3. You just close that and paste it there. Let me just do an end. Just paste it. Hopefully, if I do a config T router via GLP1, and then I paste it there, they should work now. Okay, now there's a loopback IP address that we're missing, but this one, remember, is connected to the ISP or internet service provider. It doesn't really exist per se, like physically, but let's just imagine this logical link connect us to the internet. Let's do an exit here. Let me see. Has to be config T, and then just paste it. Are we missing something here? Let's do an IP route. That's strange. It's not working for some reason. 0, 0, 0, 0, 0, 0. You can look at one. Has to be there's something wrong with this one. I need to figure that out. Loopback space one. Are we missing something here? This is invalid interface type and number. Hmm, But this is strange. I'm going to do some research. Loopback. Let's see. Hmm. Okay, for some reason, loopback one is not working. So I'm choosing loopback zero. Maybe let's see if there's another loopback that I can use instead of zero. Maybe like loopback 111. Yeah, let's just use loopback 0 because it's not working. When we try to add that loopback, it's not really working. So let's just ignore that and do an boundary Eigrp1 distribute static. That's it. That's it. I don't know if we get to 100, but we did our best and we configured the lab. If we didn't get to 100, maybe there is minus errors. We need to double check that. Okay, the passive interface, apparently. We need to configure the passive interface. So let me work on that right now. Let's go ahead and do it for all routers. Two, interface 0/0, passive. Now, how do we configure the passive interface is the big mystery. Let's go ahead and see this one with the answers to see what is the best way to configure this passive interface. Let's do an interface gateway 0/0. Let's go to router. Which one are we on? Router 2. Let's validate on router 2. Okay. Let me just type passive interface. Passive. Let me just look it up. That's strange. I don't see it anywhere. It looks like 0. Distributed static. I don't see the passive interface. This is so weird. I'm going to stop the recording so I can research. Let's see. Passive interface. Your cross interface passive. No, I don't have an idea. How to configure a router interface as passive. Okay. Okay, I think I got it. I asked GTP because I wasn't sure about how to do it, but it's actually quite easy. We should have to go to the router EIGRP1, for example, passive interface, passive internet 0/0, and WR. We have to do this with every single one. So let's go to the other devices and let's do the same. Let's do an exit, router EIGRP1, passive interface 0/0, and then keep going. Let's go to router 1 and do the same. Go to figure terminal, router EIGRP1, passive interface 0/0. Okay, I think we're pretty much done. The only thing we are missing is the IP address of the PCs. So let me configure those. Let me go work on that. Let's go to the routing table so it's easier to configure. Okay, so we are starting with the PC. Let me close the routers for now. Let me save the configuration. Let me just do the following. What are we missing here? Hosts and verbs? What are we missing? Oh, we configured those PCs with the correct information. So let me work on that. This is PC1, so let's do. Then just copy and paste it there. It's actually 255. 255 is 0. This is 1. If I'm not mistaken, there you go. Let's go with PC2. Let's do the same. Let me go ahead and copy this one. Shouldn't be that difficult. If I am able to get there, let me just go ahead to the PC because the packet tracer is a little bit tedious sometimes, so we have to be patient. Hopefully, we will be done very, very soon. We're done with this one. We just need to do it for the last one. Okay, this is actually 3.10. If I'm not mistaken, I will validate later. We have 255 and 255 and 255 at 0. And let's just validate in the routing table. It is actually one that, it is a different one, so let's just change it. Let me go ahead and change that IP because I added the incorrect one. So let me work on that and copy and paste it. I was adding the correct IP address. I just updated successfully. Let's see if we got to 100 or close to 100%. Almost. We are still missing some points, but we're at 92. So let's just save what we have so far. And hopefully we will be done pretty much soon. Let's see. Okay, the IP address for fast Ethernet 0 is incorrect for PC1 and PC and router. That's interesting. So apparently we are missing some information there. This is so strange. The passive interface here is not correct. It's not correct there. This is very much strange. Let's see if we are adding the incorrect IP to PC1. Let me go to PC1. Let's see, are we missing something here? Let's see. 172.10.0. Currently we have the, okay, maybe the default gate. Yeah, we failed the default gate. It's actually to that one. We are missing that one. To that, yeah. Let me check something here. Okay, we got everything incorrect now. The default gateway is incorrect and everything is incorrect. So it is actually lower. What are we doing something wrong here, guys? Let's see. It's so strange because it seems easy, but apparently the IP is 172.16.1. Yeah. Oh, is actually 172.1.0. 1.1. See 1.1? Yeah. Yeah. But the strange thing is that PC, apparently we are adding the correct IP, but this is the correct one. This is the right one. So maybe there is something tricky in the packet tracer lab because we already did everything perfect, but we are not getting to 100%. See, the IP address apparently is not correct, but we already corrected it. And we already configured Eigrp with the FA00 as passive. So maybe there is just a bugging in the lab because we already did that perfectly. It shouldn't be failing. The IP address is incorrect, but we did it. We added the correct one. I mean, we went to the PC, we added the correct IP address. I don't get it. Is one the default gateway? Yeah, it doesn't make any sense. Let me go ahead and save it and close it and open it again because something is wrong with this lab. Let's move to the 16. On the 0. Let's see, 1.2. Maybe it's 1.2. Let's see the PCs. 16, 1.0. Maybe start here. To the 0. Right, there's something wrong with the bucket tracer because the pin connectivity is fine. Yeah, we did everything perfectly. It's just something wrong with the bucket tracer. Yes, it is something wrong with the bucket tracer file because we did everything right. And I even sent a ping test from every PC to every single router and it's working. So it is just something wrong with the bucket tracer file. Um, I am even testing between the PCs, all PCs, and they are working perfectly. So no issues between the PCs either. So it's just something that happened in the bucket tracer. It's just not taking the configuration properly because we did everything as best as possible, but it's just this one was added correctly. We just validate those IP addresses. Yeah, we already added the passive interface command. Yeah, no, it's just something wrong with the bucket tracer file. I mean, we did testing, we validated twice or triple time. Everything is fine. Yeah, it's just the packet tracer file is just not working successfully. There is like a bug. There is something incorrect in the packet tracer file that is causing these errors. So let's just ignore it for now. Let me go ahead and do something here. Let me just go ahead and close it. Let's just go ahead and close it and save it as completed. So you will have the completed version there. And I'm going to go to the website, load this one. So you can do both the completed and the one that is not completed. Remember that it should only work until 94% because there's like a booking or something that is incorrectly set up in the Cisco Packet Tracer test. So this lab will not get to 100%, only to 94% for you guys to be aware of that. And you can study a little bit in deep detail the theory because we didn't go too deep into the theory part. We were more focused in the practical and completion of the lab because the idea was to understand the practical part. And we already covered the theory in previous lessons. So you will have all these websites so you can validate with time, try to understand better. Some of the configuration commands show running config, show run dash config, show IP route, show IP interface brief, and show IP protocols. We have pretty much covered all of them in previous lab. We didn't go too deep into those, but we completed this lab. It wasn't as easy as we thought. We encountered a lot of problems, mainly with the bugging of the packet tracer exam, but that's pretty much everything we needed to do. We configured it, and at the end, we were able to do some tests between all the PCs and all routers, so everything is working perfectly like a charm. So this is what I will do. I will share those websites with you, so you guys have those websites and also the documents. So let me create like a file with those documents for you guys to have it available. Amazing. I have it ready. So it's been a pleasure, boys and girls. I see you at the top of success. Take care, and until the next lesson, I will see you around. Goodbye.